Welcome Year 9 students. We're going to do a couple of exercises today based on similar shapes, similar triangles, and the key idea here is when you enlarge a shape, the angles will stay the same and the sides will just be some ratio of each other. So if I have a triangle that's like this, it's a right angled triangle, and you can see it's one square here, one square here. If I enlarge it by a scale factor of 3, well, it'll now be 3 squares down and then 3 squares across, but this angle will still be 90, that one will still be 45, and so the angles don't change. It's just that the sides will change, and they'll change with a common ratio, in that case of 3, because we times everything by 3. Now let's get into the exercise and have a look at what that means. So number 1, is each pair of triangles similar? Alright, well, let's have a look. Let's find this angle E. I know that this must be 40 degrees because angles in a triangle must add up to 180. Now looking at triangle LMN, if I find this missing angle M, 70 plus 40 is 110, so M must be 70. So answer to 1A, yes, because there are 3 equal angles. Okay, so that's good. Now let's move on to B. Let's find the missing angle. Angle G is equal to, 130 plus 20 is 150, so that's equal to 30 degrees. And angle T in the second triangle, 30, 40, 50, is equal to 130 degrees. Now, so that means you've got 20, 130, and 30, and the other one you've got 20, 30, and 130, so again, yes, these triangles are similar because there are 3 equal angles. And that is that bit done. Now let's move on to number 2. Okay, look at the triangles OAB and OPQ. Angle OAB corresponds to OPQ. That means that this angle here corresponds to this angle here, and OA corresponds to OP. Okay, so essentially we've got 2 triangles, and we've got to decide whether we've got this triangle here, and then we've got our bigger triangle, which goes all the way up there and down here. Okay. Part A, what corresponds to angle OBA? So let's have a look. OBA, so that's this bit here, and obviously OQP corresponds to that, OQP. Okay, let's just clear some space here. And then part, so that's AI, and then we're going to go II. So part AI, POQ. So we're going this angle here, POQ, right, that one there. Well, what corresponds to that? Probably AOB. It's the same one. Angle AOB. They probably do this little thing here in the middle. It's just showing you that's the middle angle. Okay. Alright, next one. What corresponds to PQ? So number 3. So we look at PQ. Where's PQ? PQ is this line here. The line that corresponds to that in the small triangle is AB. So AB. And number 4. What corresponds to OQ? So OQ is this long line along the bottom. So OB is the one that corresponds to it in the small triangle. I can't measure the angles because I don't have my protractor program set up on this. So all we need to do, and this is what you can do, is check. Is this angle here the same as that angle there? So you want to check that. It looks like it is. And then is this angle here the same as that one there, because they're meant to correspond? And then finally, is this angle the same as this angle? Well, yes, of course that one actually is, because it is the same angle. So if the blues and the reds are equal, then you have two similar triangles, and it appears to me that they are similar. Okay, so that's 15F. Let's move on to 15G. Okay, now you can see that these triangles are similar. We're told they're similar here, so we're going to believe that they're similar, and that means that this, you can see they've colored this angle, and that corresponds to this one here, and the dot corresponds to that. Okay, so what you do to solve these is you go, all right, the 15 of this triangle here corresponds to the 20 of the other one, and the 12 of this one corresponds to the x of this one. So you set them up like this. The ratio of this side to this side should be equal to the ratio of this side to this side. So we can just put them as fractions like this, and we should be able to solve for x. So let's go ahead and do that. Well, we will get 20 times 12 divided by 15 is equal to x. And so x will be equal to, so what we can do here is 240 divide by 15, and that's 16. I'll just check this on the calculator, make sure I haven't made a mistake. Yeah, so 16, x equals 16. So that's one way you can do it. There is another way, and you can go, all right, how do I get from 15 to 20? Right, so you go, all right, how do I get from 15? So you go 20 divided by 15, and that means I must be timesing by 4 over 3. You can use your calculator for that. So how am I going to get from 12 to x? Well, I'm going to times by 4 over 3, and that gives me x equals 16. So there's a couple of ways of doing this. You choose your own adventure, whatever works for you. Both of those ways are fine. Let's move on to B. Okay, here you can see that our x, which we don't know, corresponds to our 24. See, it's the same side. It's between this dot and this white bit, this dot and this white bit. So they correspond. And the 6 corresponds to the 18. So if we set up a fraction like this, and then we can say that x is equal to 6 times 24 over 18, and this is equal to 6 times 24 over 18 gives me 8. So that's one way of doing it. Now I'll show you the other way again. We can go, all right, on the big triangle we've got 18, and we go to 6. How do we get from there? We divide by 3. Well, we're trying to get to x, and we get there from 24 by dividing by 3. And so therefore x is equal to 8. So there's two ways of doing it. Let's move on. Number 2. We've got 3 different examples here. You'll notice on this first triangle that the 5 corresponds to the 15. Okay, and we can see that because we've got this 2 lined angle thing here, which they correspond. We've got our right angle down here, and that line is opposite the right angle. Okay, and so this is nice and easy. To get from the small triangle from 5 to 15, we're multiplying by 3. So to get from 3 to A, we must also multiply by 3. So A equals 9. And to get from 4 to B, we times by 3. And therefore B is equal to 12. Goodness, that's a bit messy up there. That didn't really help either. Okay, now we're going to try the next one. Now you can see that this 2 centimeters corresponds to the 8 centimeters, and I know that because I've got this angle equals to that one, this one equals to that one, so those two are between those two angles, which means they are corresponding. So here we go from 2 to 8, and you can see that we must be multiplying by 4 for this. So the multiplication factor is by 4. That means that D is equal to, 4 times D is equal to 12, right? Because 4 times 2 is 8, so 4D equals to 12. So that means that D must be equal to 3. And if we look at C, C corresponds to the 9. So through, what are we timesing by? 4C equals 9. Remember, we're timesing this triangle here by 4 to get the other side. So C must be equal to 9 over 4. And we could leave it like that, or we could perhaps go 2.25. I'm happy with that. Okay, now this last one, you have to be careful. So I'm going to help you out a little bit here. I'm going to color in the angles that are the same. So this angle here corresponds to this angle. So red to red. And then this angle here, this purple one, corresponds to this purple one. And then I'm going to color the last one green. This one here corresponds to this one here. Okay, now we're ready to see what corresponds to what. So this 10 is the line between the green and the red. So it corresponds to the 30 because it's the line between the green and the red. So sometimes you want to do a little bit of drawing on your diagrams to get this. So 10 to 30, and then we can go, alright, well, what does E correspond to? Well, E is between purple and green, so E corresponds to 40. Now E is on the small triangle, so E to 40. And then lastly F, which is between the purple and the red, corresponds to this 25, so F 25. Okay, now to get from the big one to the small one, we are dividing by 3. So E must be equal to 40 divided by 3. So I think, I don't know, you probably just leave it there. That's probably fine. And then this one here, we're dividing by 3 again. So F is equal to 25 over 3. And those will be our answers. You can, if you want to put them into decimals, that's fine. We're going to have a recurring decimal here. So that will be, 40 over 3 is 13 and a third. So we could put it like that. And 25 over 3 is 8 and 1/3. So we can put it like that. Alright guys, well I hope that's helpful to you. Hope that makes sense. Key idea, I think the way when this gets hard is in this last example here, and the key to solving these ones is making sure you identify which side corresponds to which means you need to think carefully about the angles that you know. Alright guys, take care.